Let's talk about spectrophotometry, especially the UV visible spectrophotometry, or also known as UV visible spectroscopy, which is type of absorption spectroscopy. And here is the diagram, which is like that having light source which emits some kind of radiation, which in turns into monochromator through slits, provide a beam of light which is split or dispersed into different band of spectra after striking the prism inside it. Different band of spectra means you have heard the mnemonics Vipjor, where V for violet, I for indigo, B for blue, green, and so on. Therefore, each band have different wavelength, and we allow only one specific wavelength at a time to exit the monochromator by adjusting the position of grating or prism used in it. Hence, the light coming from monochromator is known as monochromatic light, which is allowed to strike the splitter, and the splitter split the path of beam in two different directions in such a way that it incident on the mirrors, which aid in reflection of this radiation or light and cause it to fall into each cuvette separately. That is cuvette 1 and cuvette 2. One is a reference or other is test, respectively. The reference sample is also called as blank solution, having all the diluent present in test sample except the drug or substance which is to be analyzed. And why do we use this blank? Well, the answer is to negate or cancel out the absorbance value of diluents as well as the absorbance value of cuvette material by scanning or tearing it to auto zero. So here comes the beer-lambert law, which is the combination of Beer's law and Lambert's law. The Beer's law states that the intensity of beam of monochromatic light decreases exponentially with the number of absorbing substance, or in other words, absorbance is directly proportional to the concentration. Whereas the Lambert tells us the decrease in the intensity of radiation will be directly proportional to the thickness, or you term it as the path length of the solution. That is, absorbance is directly proportional to L. Here L means path length, also represents the thickness of medium including the cuvette material. Though the sum of the light or radiation absorbed, the rest is transmitted to detectors placed in front of each cuvette. There the transition of electrons happens from lower energy level to the higher energy level on absorbing these lights. Because these detectors are made of semiconductors having certain energy band gap between conduction and valence band, the detector read out the electron or charged particle in between these gaps as a result of transition in the form of electrical signal, which in turn display output as graphical data, which is further interpreted as concentration of analyte as well as the lambda max, that is the maximum absorption of wavelength of light by analyte present in solution, which is calculated by the data of transmittance value of sample.